before we have created this separate sub-assemblies. So now we will create this main assembly design. So to create main assembly design and to give simulation for this particular crankshaft, we need one central axis. For that, let me create one new part. On the right plane, I will create one line like this. Only for reference purpose, we need this line. So we will save this. So just we will save it as part 1. Now just we will close this. We will go here with new assembly design. Open that. So first part I will call this reference line like this. Now as you can see here, this one already it is fixed. But once if I go on visibility and if I click on origins, so two origins we are getting. This origin is related to this part design. This origin is related to assembly design. Always these two origins should be with reference to same point. For that, we can float this part. Then this part will be moving freely. So to apply relation, we'll go for mate. We'll apply relation between origin to origin coincident. Let's say OK. Then insert component. We will insert here crankshaft. And to change this orientation, we need to change with reference to y-axis like this. Then relation between this line to this cylinder, we need here concentric relation. Let's say okay. Now this part it is able to move in this direction. So to lock that movement, we can select this face. It should get attached with this front plane. Let's say okay. Now this part it won't move in this direction, but it is able to rotate in this direction. So for simulation we need this rotation, so that's why we are not going to fix this rotation. So just we'll adjust proper orientation by using front view. Then insert component, we will insert here connecting rod subassembly. So subassembly of connecting rod, let me open that. Just I'll click here, then I'll turn off origins. Now relation we need between this to this, we'll make it here concentric. Let's say okay. Just I'll drag this out. Then exactly this entire assembly it should be fit in between these two faces. In that condition we can go for advanced mates width between this face to this face. It should be exactly inserted between this face to this face. Properly it will come at center in between these two faces. Let's say okay. Just we'll make it here Ctrl+1 to keep it front view, and we'll adjust this orientation properly like this, isometric. Then next to that we are going to call here new subassembly design of this piston. So insert component, subassembly of piston. Let me open that. We'll keep it somewhere here. Then we need to apply relation between this cylinder to this cylinder. We'll make it here concentric. Let's say okay. Then next to that we are going to apply some different relations here. So this piston assembly exactly it should be center of this thing. So same as we have used earlier, we can go here with option. So we need width between this face to this face. It should be exactly center of this face to this face. So properly it will come at center like this. Then as you can see, if I try to move now, so if I click on Ctrl+1, this piston assembly's position is not proper. So what we required here, this piston should be able to move only in up and down direction. So in these conditions, just we will show here this temporary axis. Now we are able to get axis for this piston assembly. We'll apply relation between this axis to, we will select here this right plane. Properly that axis it will come straight to that right plane. Let's say okay. Now just I'll turn off this. If I keep it on front view by using Ctrl+1, if I rotate this, this will be rotating. Piston will move only in linear direction, up and down movement like this. isometric. Now whatever we have applied this connecting rod assembly and piston assembly, same we need to repeat all these places. So if you want from here, you can just forward that video, or else you can increase the speed of the video. Now let me make same the sub assemblies here. So instead of calling insert component and making separate sub assemblies, directly we can use one option called copy with mates. So let me go with this assembly first, connecting rod assembly. So just we can open here. We need this sub assembly of connecting rod. Let's go here with the next. First we have applied concentric to this. Then width between this face to this face we wanted. Then next to that we need concentric between these two. So let me select this. So just we will click here. I will make this cylinder selection. Now same the sub assemblies we need to insert all these conditions. So instead of going for insert component and inserting again and again, we can go here with copy with mates. We need to copy with mates of sub assembly of connecting rod and sub assembly of piston. Let's go for next. We need concentric relation for this. Then width between this face to this face like this. Then next to that, coincident we need with reference to this front plane. This right plane I'll select. Let's say OK. Now same again we need to repeat same subassembly for this cylinder. Width we need between this face to this face. Then parallel to this right plane. Let's say OK. Again here also we need concentric to this. Width between this face to this face. Then coincide to exactly with reference to this right plane. Let's say OK. At end we will cancel this. Now as you can see, properly these sub-assemblies were assembled to the main assembly. If I click on front view by using Ctrl+1, and if we try to rotate this, proper orientation we have achieved now. So now we will go here with simulation. So in a simple method we can apply this simulation. For that, let me keep it in isometric view, and here it is showing to make it rebuild. It is nothing but update. We can click here for rebuild. Then to make it simulation, just we'll go here with motion study. So we need to apply some motor here. So to apply motor, we can click on motor. Here two type of motors we are having. One is rotary motor and one more is linear motor. We need here rotation. So just we'll go for rotary motor for this shaft. Either we want rotation in this clockwise or anti-clockwise, we can change by using this reverse direction. So let it be in this direction. Then speed we can adjust here. Let it be 100 rpm and let's say OK. Then next to that, we need to adjust frames per second for visual display properly. We can go here with this motion study properties. Frames per second, we will keep it some 60 here. Let's say OK. Now if I click on calculate here, just it will calculate whatever the parameters we have assigned for that particular assembly to make it simulation. Let it calculate first. Then next to that, we can increase or we can decrease the speed of that motion simulation. For example, I'll keep here 0.25 like slow. Then we are able to change different orientations here. Like normal means only in one direction from starting to ending it will come. If you make it loop mode, again and again same step will be repeated. Again reciprocate means first it will go in clockwise, next it will come in anti-clockwise direction. Now for this one we will make it here loop mode. Just we will click on this play from start, so you can see proper orientation of that particular simulation of this engine assembly. So in this way, we can create this assembly design and we can make it simulation like this. So let it complete here. As we have kept here loop mode, again and again it will be continuously repeating the same process like this. Now if you want to stop that, just we can stop here. Then just I'll adjust to starting. If you want to save this animation, just we can go here with save animation and we can save this. Or else just you can minimize the screen and again you can play from start. Proper simulation will be able to see here. So just I will stop here, then I'll adjust here. I'll make here save animation. So we need to save that in which format we want. We are able to select here. So just I'll click on here MP4 video format and just I will make it here save. Only simulation will be saved in MP4 format. So just it is going now preview. So once if it is done, video will be saved onto our local files. So in this way, we can save this animation videos also. Now let me check how it is saved. So for that, just I'll go for files. So we have saved under this engine. So MP4 video is available here. Just let me play that. Proper animation we are able to see like this. Thanks for watching. Keep supporting. If any doubt you have regarding this, you can just comment it down in comment box, or any suggestions or any improvements if you want from my side, just you can give support from your side. Once again, thank